Hello, and thank you for joining us for this week's Ask Joe. The topic this week is going to be the GIS solutions from Spectra Geospatial, where you will learn about the variety of hardware options that we have, as well as how each can be configured individually for your accuracy requirements. Multiple data collection applications are available. Joe will cover MobileMapper Field and Office in the presentation, as well as going through a live sample of a project afterwards. Presenting today is Joe Sass. After the presentation, please ask Joe your questions about GIS and MobileMapper. A little background on Joe Sass. His title is Channel Development Manager, and as a field application engineer, he is the liaison for us between product marketing, sales, and engineering. He has a degree in geography, blends nicely with his passion for surveying and GIS. Since 1998, he's been active in the California Land Surveyors Association, and in 2004, he has began representing us with the RGCM Standards Board, and he currently sits on the board of directors of that. So with that, I invite you to listen to Joe Sass, and Joe, I will let you take it over from here.
Thank you very much, Mr. Binder. I hope everybody out there is having a nice day or evening or afternoon. For me, it's morning. I'm in California, and it's going to be 100 degrees plus today. So I'm going to turn off my camera now. You guys know I'm live, so I'm not a robot, and we'll all be better off without seeing me, I'm sure. So GIS portfolio review is exactly what we're going to do. And so really the legacy or the history of my company has gone through several names throughout the years, and different ownerships and partnerships. Going back 1993, I actually have one of those units. I think it's called the TrackMan or something like this. Talked to Carlos Escudero down in Chile. He has one as well. Still works. That device shown in under over 2000, year 2000, that's the ProMark II. And that really, I would say, in that era when we were known as Aztec, put us on the surveyor's radar. And back in that day, you could buy 3 of these in a pack and all fit in one pack, and you could go out there and do a static survey and develop control. It was 3 units. I think it was a very compelling unit for its time. And during that era, we were affiliated with Magellan. And Magellan, as you may remember, is a consumer brand of GPS. Back then it was just GPS. And they had a whole bunch of engineers who knew how to miniaturize things, but didn't know a lot about GPS. And we had a bunch of engineers who knew about GPS, but didn't know necessarily about miniaturization. And together, we were able to put together some very compelling handheld units, as you can see here, coming up to the present day where we're out with the MobileMapper 60. As I mentioned earlier, the legacy MobileMapper name goes way, way back, and there have been many iterations of it. What I didn't put on that list on the right is MobileMapper Office, and I'll get to that later, but I mention it because so many times I get a request for help and they just tell me it's a MobileMapper. Well, as you can see, that's not quite enough information, and we need to get more specific. There's been many generations. What you're looking at right there, and you may have seen in the background when I had my camera turned on, is the MobileMapper, the original MobileMapper. That was the one that says Linux next to it, and that was, if any of you know Charlie Branch, that belonged to him. That was his product, and that was the first in a really long legacy that continues to this day of the MobileMapper brand and performance. So today, if I had to capture our portfolio offering in a single slide, I've done it here. It's not a very complex portfolio, but it is a compelling portfolio with many unique features and interesting propositions. On the left, we have the SP20, which is a combined Android platform data collector with a smart antenna that's built in as a single unit. So it can be a handheld, and I'll show you later other configurations as well. MobileMapper 60 is our, what should I say, the Android du jour, the current version of our of our ruggedized Android platform from which we run our software. And then if you look over quickly to the right, you see this application called Space. And when I use Space, I can then use almost any third-party software that runs on, or native software of my own, and combine it with a smart antenna and get my GIS down to centimeter level. And we'll talk about that later. On the right, the field software primarily offered by Spectra is the MobileMapper Field, which is a GIS field data collection software. MobileMapper Office is its complement in the office. It does the post-processing and does a good job of data visualization. I'll show that later. And then the Space. I like to refer to Space as middleware. It operates in between my destination software, let's say that's Collector from Esri, and my GPS, which might be that SP60 on the left, running on my Samsung phone. So as you know, Collector can run on any Android platform, and so can Space. And so I'm not driven to purchase a Spectra MobileMapper 60. I can use any open OS, I think it's version 4 or later, and match it with Space, and then just about any third-party application, or if you prefer, my in-house MobileMapper Field software, which offers a couple of advantages that the third-party apps do not. Let's talk first about the SP20. Android 6. I'm not going to read these to you. I will just say that, you know, when it says Gorilla Display, that means it's the same glass that you have on your iPhone. It says cameras. There are 2 cameras there, and you can see the environmental specs as that last. High accuracy, it is centimeter capable. Now, obviously, with a small antenna like that, and maybe at waist level, you might degrade that a little bit, but there are ways to achieve centimeter RTK capabilities with this unit. It does not use a radio, so it relies on the embedded cell phone or a Wi-Fi connection, hotspot connection to the internet to get the NTRIP type corrections. The SP20 can be scaled. So it can be a unit that just receives the GNSS from sky or the GPS from the sky. And that's going to put you, especially in North America, where most of us are probably, in the meter range using the WAS corrections or any S. And then from there, we have scalability options that allow you to be sub-meter, decimeter, or down to that full RTK. The antenna on this unit is L-band capable, which means that you can get the field point RTX either through the internet or through over the air from space. And if you were to say buy the sub-meter or the decimeter or even the meter unit and later decided that you wanted to upgrade to a higher level of accuracy, there is a price penalty, but it is a possibility as well. And that was not my drawing. I stole it from someone else, so I take no credit or blame for it. We in-house, meaning Spectra Geospatial, we have 2 pieces of software that are data collection oriented softwares that run on the Android platform. On the survey side of my house, I have Survey Mobile, and in a future presentation, I think it might be on June 18th, I will do a presentation on the Survey Mobile software if you're interested in that. And on the right there, you see my MobileMapper Field, which utilizes Space, that's that second icon there, to get the corrections from the internet. So Space negotiates the NTRIP. Most of us are familiar with NTRIP. It also does direct IP connections, which are less common. But either way, this is my middleware. It connects my high accuracy portion of the GNSS proposition with the field software. The 3 different ways it could be configured. I don't know that I need to say a lot about that. The unit automatically comes with a pole bracket, so that if you want to run with a 0.5 meter or a 1 meter pole that's extendable to like 1.4 meters, we sell that range pole that you see there, and we also include a pole bracket with every unit so that you can have it on if you're going to use this, or off if you're in either of the other two configurations. I show right here the SPGA rover antenna that Spectra sells, but the reality of it is it's probably good with any high accuracy antenna. When you work for a large company that has talent from all different types of spectrums, you come up with innovations like this, which are a beautiful thing. Hopefully I can explain this, but when I'm using the monopole, I'm somewhere between 1 meter and 1.3 or 4 meters. And typically, if I'm on a monopole, then I don't really have an opportunity to use a level vial to get myself level over any point. And if I really want to achieve that 1 or 2 centimeter accuracy, I needed another solution. Lo and behold, we've got a brilliant photogrammetrist in our office in Paris, France, who happened to be working with an engineer from Spectra. And he says, hey, I think I can solve this. And he solves it through photogrammetry. So what you're seeing here, using the inertial sensors, we know when the two circles line up, the bigger circle on the outside is stationary and related to the height of my pole, while the smaller circle is dynamic. And when I move the pole around to a point where I am level over the point, I will get that middle symbol there with the two green circles telling me, yes, you are level over the point. And I show that screen capture on the far left to indicate that when I change the height of my antenna, that bigger red circle moves up or down on the screen. And that's how it knows to circle one against the other. It is a really nice routine and solves a problem of not having a level vial. But even so, it's much nicer than using a level vial. You still have the opportunity to, but this is an alternative method to collect the data. By the way, that only works on the SP20, right? And it works with the Survey mobile software and with the MobileMapper field software and no other software. Here we've got the MobileMapper 60. This is a ruggedized Android platform. And I'll let you have a moment or two to read the specifications. I feel like I need to put these up on every slide. If you're going to cover a product, you should cover its specs. But increasingly, I think we look to performance and not spec, but sometimes within tenders, specs matter. So here they are. And I just chose the ones that were interesting to me and not in any way comprehensive of the specifications that you would find on the data sheet. So the MobileMapper 60, if it's standing by itself, getting SBAS corrections, as you see on the far right, you're going to be somewhere around 2 meters of accuracy. And if you combine it with a smart antenna, you can go way down to 30 centimeters, down to 1 centimeter. And again, I show space there because space is actually the middleware that connects my MobileMapper 60, insert whatever software you want, and hook it up with an SP60, an SP80, or an SP85, and you now have centimeter capability. Understanding that and I haven't talked about it yet, but the SP60 is a scalable receiver as well, so you could buy it at that 30 by 30 centimeter level, even though it's centimeter capable. So again, we've got the MobileMapper 60, can run either of my software. If I want to get corrections using the Survey mobile software, it negotiates the NTRIP connection directly through its own software interface. Whereas if I want to use the MobileMapper field with RTK type corrections, then I need to use this middleware we call Space. And Space, again, works with most Android softwares. Just some use cases on the right there. You see it being used in high accuracy mode. I like the bottom middle one showing this is certified as a cell phone. This is where I choose to have my SIM card, my extra SIM card. And to be in fact about it, it has 2 SIM slots. So it can be two cell phones at once. Some people use one for data, one for phone. So flexibility comes with the hand strap you see on the left. By using this middleware we call SPACE, Spectra Accuracy Enabler, I just show a sampling of the Android apps that can be run. Maybe you recognize some of those apps. In fact, in the middle top, that's Google Maps, right? So if you wanted to not only know what street you're on, but what side of the street or what lane you're in or what side of the lane you're in, you could hook this up with RTK, and then when you display this in Google Maps, you are now at the centimeter level inside that framework. So SPACE connects to a GNSS receiver. Here we're going to connect my Android, probably a MobileMapper 60, to my SP60. It's connected via Bluetooth. My receiver does not have RTX. And then here, it's got the RTK option, which is a purchase option of the receiver, not of SPACE. So I kind of did some photoshopping here to be able to display the full list of settings that you'll find inside SPACE. I don't really need to go into a lot of them. If you want to just record raw data on the SP60 or the SP85 head, you can turn this on and record raw data and get continuous survey data from that. If you need to do data NMEA out or NMEA recording, we have that ability as well. Some networks that are in the VRS, for instance, need to know where you're at, so you can keep the NMEA outputs running so that the VRS is able to compute your virtual reference station. This is a long sought after one. Some of you on the call may be interested in the location extras for some of that metadata from Esri that we were not capturing before. Since the advent of their Aurora project and its release, we're able to get a lot more data out in the way you want than previously. I don't need to go into the rest of those. Here we've got a sky plot. It shows both the satellites in view and the satellites being used or unused in this case. When it shows a battery icon, it's showing me the battery icon of my receiver that's connected. Very convenient. Positional information. You guys now know roughly where I live, so I won't stay on that page. Probably got screen captures already. Correction information, so I'm using NTRIP. Here, if I clicked on there, I'd have a choice of NTRIP or direct IP. It's been to this mount point before, so it would automatically reconnect. And you can see the age of correction, the base station ID, and the fact that I am connected. In order to make this configuration work, you have to enable the developer options on the Android operating system, whether that's your phone or the MobileMapper 60. And I show you here how to get there. You tap on build number 7 times and it says voila. Here, maybe not, maybe in France it says voila, but it says congratulations, you are a developer. And then once you're a developer, you go into these mock location settings, and again I show you where that's at, and you make sure that SPACE is allowed to access this mock locations, which allows SPACE to redirect that incoming RTK stream to another piece of software. That's the middle part. And you can see Trimble has something similar. Trimble Mobile Manager is a similar type application. I'm not sure about its use, but it still requires the same level of access where you have to enable the developer options and then assign it to software for it to use those mock locations. Oh, did I miss one? You guys missed an important slide. Wow, picture slide. Those are the easy ones. You don't have to hear me talk as much about those. So a little bit about the field software. When I say easy to use, I know that that's a marketing term, but as a technical guy who's not in marketing, it is easy to use. There's not a lot of complexity to it, but there's a lot of utility to it. I show here where I've loaded up some shape files. The little blue dot is my current location. These other bigger blue dots are shape files. They're point features out there near me. And if I click on it, I get to see the northing and the easting. It's shapefile based. And you'll see that there are some other file formats we can use, but I'm going to concentrate on shapefiles because that's really the primary file format for the software with the most amount of flexibility and functionality. And one of the things that my MobileMapper field Android-based software does that others do not is offer the ability for post-processing. So if I'm in a place where I have to set up my own base station or I need to use local cores, I have that ability and I can still process down to a centimeter, and we'll go over that a little bit later. Got a go-to feature. So it's telling me I'm the little blue dot. I want to go to that big blue dot with the flag. It says, go that way, young man, 367 meters and you'll get there. You know, I guess the young man was my wishful thinking, but well, I'm going to stick with it. So here you can see within a job, a MobileMapper field, I have uploaded several shapefiles. You can see the shapefiles are either point, line, or polygon. That's what we support. And these are just, you know, everyday shapefiles. They're not part of a geodatabase in the sense that other softwares feed in and out of the Esri suite of software. But the Esri suite of software has the ability to generate shapefiles, and that's what the software really needs. Here I'm logging a point feature. So I have the ability to start logging and still enter descriptions and feature. I can either type in these features if they came with a dot, if the shapefile came with a .mnu file, the menu, then I would have the drop-down selection of all of the features under this attribute. And then this little red button is how I would start the log. Before I start the logging, I can make sure I've got the correct antenna height. I can, for instance, put an amount of time to be on point before you actually store it, or I can do some offsets here. Here I'm logging a point. It says I've got 23 seconds remaining. During this logging period, I could be entering these values. There are some preset values that I can also choose to automatically populate, like date and position, those types of things. I get my status bar up here showing the horizontal precision and the vertical precision and the RTK information here. And then the save feature here. In fact, if you are on a Google platform and you're comfortable working in that Google environment, when you press the save button, it will save directly to your Google Drive if you're connected to the internet, and if you have selected that save option. So the job menu, I've clicked on these three buttons, these three dots down here, and that pulls in this menu. And to import the shapefiles, I use the import feature. And at the end of the day, when I'm done, I use the export function to export those shapefiles because they've been updated. I've got various settings here I think I go into, and we'll talk about them. Here we can see the different options here. I've tried to list them. I'll just keep my mouth shut for a little bit and let you look at these. The record raw data, if I were to click on this button and turn on the recording of raw data, and I had an SP60 or an SP85 hooked up, and I did not have a license for it, I would then be presented with a screen that would ask me for my POPN number, and I would have to be connected to the internet, and it would go out and authenticate that on my Trimble server, and then recording of raw data would be enabled from thereafter on this issue of MobileMapper field. This license resides inside the field software and not inside the GNSS you're hooked up to. So my export options, so we do support the map info files. Quite honestly, I've never seen one, so I wouldn't recognize it except by its extension. We can export all of this data as CSV or in DXF. Typically, we're going out as 2D or 3D shape files, and that's what I use for my examples today. Goes inside a directory on the root of the Android file system called download, and that's where you'll see the result of this export. Here's clicking on that post-processing option, being asked for the proof of purchase, making sure up here that I'm on the internet either by Wi-Fi or through my cell phone before I click register. We have the ability to do what they call nesting. So I could start a polygon and then pause it, and I could step off to the side and collect a point like a fire hydrant, and then I could come back to the polygon and resume. So we have this idea of nesting is what I used to call it. We don't call it that now, but that's what this is trying to say, is that you can pause a feature and insert a feature so that you're not having to do backtracking. And I'll show an example a little later also of another way that it's used as well. Be aware that features can be deleted. That's been asked for a lot because people make mistakes in the field, but it's a double-edged sword. Just be aware that you can. Your guy in the field could clean up the data before he gets to the office, or he could delete something accidentally that was important. And then you can also load geoid models. I know it says Aztec, that's just a legacy thing that we haven't found a new home for them. Not a lot of people in GIS are used to working with geoids these days. A lot of software expects the data to come in with ellipsoid heights and models the geoid inside the field software, but we do support them inside the field software. MobileMapper Office, it's our post-processing tool for the data that you collect in the field, the raw data, but it's also data visualization, right? So here's just a generic shapefile. I'll get into this a little bit later during our live demo, but this is just a generic shapefile, and if you have shapefiles laying around your office on a USB key and you want to see what they look like and you don't have a licensed piece of software, go to the Spectra Geospatial website and you can download this software, and it costs absolutely nothing, and it gives you a great representation of the data that's inside those shapefiles. If you wanted to create your own shapefiles, let's say you wanted to create a template for a fire hydrant, you could create a new point shapefile, and you could go through and list all the attributes and the menu choices and the mandatory fields and integer values and all of this stuff through this interface, and then use that in the field. And both of those, both the data visualization, management, archiving, and the preparation or creation of shapefiles, this software costs absolutely nothing, and it's dead easy to use. You can upgrade to the post-processing, and you can upgrade to the centimeter post-processing. I didn't put the post-process. There are times when you're using like a MobileMapper 60 and you're not using a smart antenna. And in that case, you would want to be able to improve your position from the 2 meters you get with WAS or SBAS, understanding you're never going to get to a centimeter. And that's where we have this code carrier post-processing option that should get you down under a meter, even with raw data from a MobileMapper 60. So there are 3 identical jobs. I did 3 jobs right in a row, and I did exactly the same thing on all 3 jobs, but I did them with different pieces of hardware. And I wanted to show you visually what you get out of the data collector when you're bringing it into the Office software, right? So I collected 4 points, 4 lines of polygon. You're going to get sick of hearing that because that's all I know, it seems like, today. Okay, so exactly the same in each job are the shapefiles themselves. Right? You can already see a pattern beginning to emerge, right? You're going to get the most number of files when you have an SP60, which has that rich centimeter type data, versus the MobileMapper 60 raw data, which is not so rich and is not so precise, right? So you get the map file, and this map file is it's the shell of the walnut, right? It's what wraps everything together, and it's the same in the office as it is in the field. So when I go into the field software, I'm actually opening up the map file. When I go into the office software, I'm actually opening up the map file, right? So they know how to attach all of the data that's associated with them. And then we can see the differences in the raw data. There is no raw data when I'm just doing MobileMapper 60 RTK, right? And when I'm doing MobileMapper 60 post-processing and I'm using the MobileMapper 60 raw data, I have these .crw and .urw files, whereas when I use an SP60, I get these other types of files with Julian dates on them, right? So this right here, just so you know, the A stands for the first file of the day 133 of the year 2020. And that's how you read that. These other numbers have to do with the serial number or other receiver IDs that are hidden inside. So in the MobileMapper office, I'm saying the typical workflow. I'm actually going to walk through a live workflow doing exactly the same thing or nearly exactly the same thing. So you open this map file that you took off the data collector. The data is displayed. It has not been post-processed. So we add rover raw data here. We import that rover raw data. You can see that there were two separate sessions of raw data. The data file was turned on, it was turned off, and then it was turned on again, and the second session was slightly longer than the first session. We then can import reference data. The reference data can be from the internet or from a local file. I believe in this case it was a local file. That local file, this file right here, the yellow line, is a base station on the roof of my house. And I took over 2 hours worth of data that was coincidental with these occupations, and I sent it to Opus, which is the free software, the free processing service of the National Geodetic Survey. By the way, that works worldwide, not just in the US. And I fixed my base station position by highlighting it right here. You can't see it in the screen capture, but I highlight this line down here, brings up these points. I assign the state plane coordinates that Opus has told me with an orthometric height. And now I can post-process the data. And I get the data post-processed. Just a point about that. I think this needs some explanation that's not immediately obvious. When I collected this blue polygon, there are 4 corners to it, obviously. But what I did was I collected up this point, and then I started the polygon, and I immediately paused it. Remember earlier I said I could nest, so then I started a line feature, and I walked this. That's not true. That's not true. I think I made 2 passes. As soon as I started this polygon, I paused it. Well, that start and stop is probably that vector there. But I paused it until I got over to this point, and then I started and stopped it again. And same thing, I came down here, I started and stopped it again. On this one, I didn't. I just let it go, and I walked this. And if you'll see when I zoom in, you'll see that this line is a little bit more ragged. It's not as straight as these other, because these others are just connecting 2 points. Whereas this line that I walked has all these vectors, and these vectors are what contain the accuracy element of the post-processing or of the real-time information. Notice also over here we have final, post-processed, and original, right? So shape files are database files, and so there is no save as feature. They change as you change them. So if you go out and you have 10 fire hydrants and the data file is 100 kilobytes, you go out and collect 4 more fire hydrants, it's going to be 1,400 kilobytes. It's cumulative. We want to preserve the original data, so we do nothing to those original shape files. There's this intermediate step where we're post-processing the data. You may have additional adjustments, and then we have these final coordinates, and this is the deliverable, are these final layers, and that's what you send out to your GIS. Just zooming in on the 4 different times I ran this loop in the various configurations that I ran those in. Doing RTK was very clean. Doing the post-processing was very clean. Doing post-processing with just the MobileMapper 60, not so good. It's data, garbage in, garbage out, I think they say in data processing language. Here, MobileMapper 60 with an SP60 on top. This is the original data as it comes into MobileMapper Office. This is what it looks like after it's been post-processed. I show you the before RMS and the after. And I get an art. I need to fix this. This is a post-processed fixed solution, not an RTK fixed solution. But I would expect similar results either way, so it's not necessarily wrong. Also, again, take note of what I told you earlier, that I just, for these lines, I just connected points at the corners, at the vertices, which is why these three lines are so straight. And yet you can see I did a continuous where it just, no, I had not had anything to drink that day, but you can see I meandered a bit as I walked between those 2 points. And that represented all those green line vectors that you saw on the previous page. Internet download, so it can automatically bracket your field data and go out to the internet, and you can either search by a number of stations, irregardless of how far they are, or you can search by a distance where it will return as many stations within that radius as you specify. You can export the data from MobileMapper Office to Google Earth. Here's a representation of the polygon that I use as my demonstration. And then just a brief word. I've talked about the SP60, which you see here on the right. This is the SP85 on the left. There's also the SP80, which is still being sold, but these are the two, flagship products of my company right now. Just a little bit about that. The SP85 is recently released. It's compatible with Centerpoint, so if I'm in the middle of no cell coverage, no base stations, no corrections, I can still get Centerpoint over the air through the Trimble correction services. Tracks everything in space just about. There are some exceptions that are not worthwhile to North Americans anyhow. I think that there are some exceptions with some exceptional signals in Japan and India. And none of those satellites make it over the United States, or for that matter, the Western Hemisphere. So it's not really important, the signals that we do not track. The front panel interface and display of the SP85 cannot be underestimated. It's a powerful, powerful feature of the receiver. There are so many things I can do from the front panel that make a data collector less required. What do I even say that there's a web interface? Can't believe I didn't say anything about that. There's a complete web interface that I can connect to through the Wi-Fi connection, and it can be a hotspot, it can be an access point, it can be a client, and I can, if it has a SIM card inside its SIM slot, I can actually use this like a Starbucks hotspot, and I can get my iPad and tablets that don't have internet otherwise onto the internet through this SP85. SP60 is just a solid workhorse of my portfolio. The price performance ratio is compelling at many, many different levels. Regardless of your GNSS use, the fact that you can take this from a meter level unit, just getting good high quality GNSS data, let's imagine that I'm in North America, I could set this thing up on over points for 15 minutes or more and then send that data to Opus. And now I've got a centimeter solution from Opus that is, I didn't have to work very hard for. And that's probably at the low end of the spectrum of price, and yet it goes all the way up to tracking, tremendous number of satellites in space. It appeals to a very broad audience against many different vertical markets, from construction to marine to land survey to GIS, on and on, machine control. So it's a great data collector that I'm very proud to have in my portfolio. And that is the presentation. And that was going to be it. And then Joe Binder had a brilliant idea. He said, Joe, why don't you do a live demo after you're done with the presentation? And so I prepared that same data set that you saw inside the presentation, and I thought that we would work our way through it in a matter of just 5 or 10 minutes, and then we can open it up for questions after that. So I want to talk about this data set, right? So this is my neighborhood. I'm not going to tell you which house I'm in, but at one point several years ago, I wrote to my city and I explained to them the business that I was in. And I said, would you send me all the shape files for my neighborhood? And they did. And that's what you're looking at. Not all of them. They sent me other layers that I don't have here, but they sent all of this to me for free, and I use it as a demonstration tool. This is just free source, open source shapefiles out of anybody's database, and I'm able to visualize the data. And let's say that my eyes don't really talk to green very well. I can come over here and I can change that. Come down here and like, no, don't do green. I'd rather see blue, right? And my instant database changes to blue. Let's say that I'm at my job level and I don't want to work in miles. This job, I want to work in kilometers. I can change these things on the fly, so I'm able to visualize my data in whatever datum or whatever units I'm using in my job. The number of attributes within a shapefile can be extensive. You can see here that on this point feature, it's a CIP, whatever a CIP is, and it's got its position, it's got other things about it that were important to the person who set up this template for the database. Other features here, this one, if I go to a polygon type feature, it will give me the perimeter and the area of that polygon feature. If I click on a line feature, click on a line here, it will give me length right here, 1961. So again, this is a great tool just for visualizing GIS and any GIS, right? So it doesn't have to be something that's related to a GNSS project. It might be just whatever. This is a free piece of software that's dang easy to use. So what I thought I would do, oh yeah, I thought also I would show you this license manager here, right? So currently installed feature, post-processing with sub-level accuracy, sub-meter level, and then post-processing with the centimeter level of accuracy. And this is that purchase option right there. I believe that this one comes by default. I don't remember getting that license myself. I think that might be installed as part of the software. Yeah, so let's work through a sample data set. I'm going to open an existing map. This came from the data collector. I'll go to open, and this is going to be Ask Joe, and here's my demo map. Now, notice that the software is only showing me my .map file, but if I open this up, there's a lot of other stuff there that came along out of the data collector, right? So my map file, and I open it up, and there's those 4 points, and they have not been processed. 4 lines, 1 polygon. You can see them over here. Again, if I didn't like that turquoise color, I could say, no, make it a dark blue. And voila, it's dark blue. So I have control over how this looks. And all I have is my real-time data here. If I were to scroll in here, you can see definite misclosure here, right up here in the corner. This is the corner. This is where the 2 lines started and stopped. This is the corner of the polygon. So nothing really matches up very well. It's real-time data. It's SBAS data, right? It's coming from the SP60, but it has no correction other than SBAS. You can see my scroll bar down here, 20 centimeters. So, you know, I'm sub-meter, I'm half meter, but I want better than that. So I need to add the rover raw data, which is this button right here, right? And here's my Ask Joe, here's my rover raw data. Because this is simulated, I typically, this is going to be my base station data down here, that last file, but I'm not going to do that yet. So I'll open that up. So now you can see I've got 2 rover sessions representing this data set where the data was turned on and off. And this data set goes from 741 to 756. Shame on Joe Sass, right? A raw data file should be hours long. It shouldn't be minutes long. I get people that send files that are 38 seconds long. That's not a raw data file. Mine barely qualifies as a raw data file. It takes 12.5 minutes to get the full ephemeris data of GPS over the air from the satellites themselves. If your receiver is not run in a while, that can be an issue. There are just so many reasons to have long and better. I should not have turned off the raw data file. I should have left it running. Even if it just sat and did nothing and I wasn't using the equipment, I probably answered a phone call maybe here. Should have just left it running. Shame on me. I'd like to say I used that as an example and intentionally built that into the data, but I didn't. So I've added the rover raw data. I can add reference raw data, and I can go, as I said, I can go to the web, right? And I can say, these are the rover files for which I want you to find the data, and I want you to find the 3 closest stations to me. And it goes out on the internet, finds this Mills filtration plant, Crafton College Hills, and the Esri GISA. So I could bring in this one, and maybe I'll do it later, but probably not. So let me see. Let me come up here, take just a slight detour. Before this began today, I went to the internet and I found on the NGS data site the NGS sheet for the GISA core station, right? So it's got, if I have to enter my values in Latin long, here's the current survey control. It also down here lower presents them as state plane coordinates. So if I need to present the data as state plane coordinates, and it's got the values that I could feed into MobileMapper Office. And so that's one way, but I'm not going to do that right now. I'm going to cancel this out, and I'll just import this reference raw data from my file. And that's this file right here. So here you can see my reference data is overlapping all of my rover data. I could come in here, and I actually did process an Opus solution, and I plugged those Opus solutions in right here. So if it wasn't 623 and it was actually 625, I can change it there. And I can do that with my northing and my easting as well. Because the shape files were created with state plane coordinates zone 6, that's why the coordinates here are presented. Part of the shape file is a file called the .prj, and it contains this information. So I've imported it, I've fixed my base station position to the correct location. I'm now ready to start my processing. Okay, so this is again what we saw inside the presentation itself. If we come back up here to this corner and look at it again, we might get a little bit better feel for what's happened there. Now I'm at my maximum zoom of the software, which is 10 centimeters, and pretty much everything fell. I would say if that's 10 centimeters, that's 1 or 2 centimeters right there. So everything came in nicely. Got a couple of these green vectors coming from the polygon where I just stood on the corner for a minute. I've got one at least coming in to close this line, and another one at least for the point feature that's here. If I needed to get a better view of these, I could, for instance, turn off the polygon. I could turn off the line, and I would then, those were my vectors, turn off my line, and I could see my point feature. If I click on any one of these vectors, you can see that it's a 49-meter vector that post-processed down to 9 millimeters horizontally and 1.5 centimeters vertical with a PDOP of 1. And that's the solved location. And that solved location is representative of this final, right? So we have the original, we have the intermediate, where things might have changed. I'm not really confident that I know or understand. I've never used that file, post-processed one, but I know that the deliverable here is the final, and that contains the coordinates that were derived from the vector right here with that level of accuracy. And I'm not sure why, but we separate the vector from the actual feature itself and create a new shapefile that we call vectors, and we'll give you a pass and fail. And as long as you've got good data with good reference data as well, you shouldn't get any fails. And with that, I guess I can go export, or not really. Export if I want to export a KML file, or export if I want a GPX, which will show the track, or CSV, which presents all of this data in a CSV comma separated value format. Otherwise, I don't need to export, right? This data is in my File Explorer. If I go back here to the job, I think it's here. Office job, Ask Joe. And here you can see these are the finals for the point, for instance. For my point feature, that would be the deliverable. My line feature, that's my deliverable, and so on with the polygon feature. So, coming back to here, I would like to say thank you for attending in whatever language you happen to recognize up there. And if there are questions, I'm wide open for them at this point.
Well, thank you, Joe. Very informative. At this point in time, no questions have come up. And
that
if
speaks
anybody
to
does have any,
presentation, right? Thank you all.
Well, we appreciate you all spending the time. Oh, yes, somebody is asking if we recorded the session. Yes, we have, and that will be posted. I believe it takes a day or so for them to post that
to the portal that's shown on the page right now, by the way, and it is restricted to our dealers, who can resupply it to you if you're an end user in the audience. I took up almost
all right. Well, look,
made up for the other weeks where I didn't.
Okay. Well, if there are no other questions, again, thank you. We appreciate you spending the time and joining us on this Thursday, and look forward to meeting with you again next week on Ask Joe. Thank you.
Thank you. Bye-bye.